Find the exact value of the six trigonometric functions of the given angle theta. So notice that we don't know the given angle theta, right? We don't know its value, but we can still find the value of the six trig functions because they are based on the ratio of the sides in the right triangle. So we are given this right triangle where theta is in this upper left corner, and we know one of the non-hypotenuse sides, right, 3, and then the hypotenuse is given as the value of 4. So the first thing we can do is find the value of, let's call this side B. And notice we can't use our special right triangles here because we don't know what theta is, right? We don't know if we're in a special right triangle, but those will come in handy later. Okay, so we'll start with 3 squared plus b squared is 4 squared. And then we get 9 plus b squared, 16. B squared equals 7. So b is the square root of 7. All right, so b equals square root of 7. Now, if I'm a little guy standing up here in the corner, and then what would I call these three sides, right? What are they in relation to me if I'm standing up here at angle theta? Well, the hypotenuse is always the hypotenuse, but this side B here is kind of opposite, right? It's across from me, so this would be opposite. And then this side here next to me that has a length of 3 is adjacent. All right? And we never want to be shy about writing out our SOHCAHTOA somewhere. So SOHCAHTOA, and that'll help us remember how to find the value of each of these three trig functions. So I'm going to start out and say, what is sine of theta? So sine of theta is opposite over hypotenuse. Opposite is root 7, and 4 is the hypotenuse value. Now, normally I'd want to simplify this, right? But this is already simplified. There's nothing else I can do, so I move on. Here we want to find the exact values too, so we don't need to enter this into a calculator at this point. All right, cosine of theta, adjacent over hypotenuse, or 3 over 4. Tangent of theta is opposite over adjacent, so root 7 over 3, and again, I'm done there. All right, so let's look at cosecant of theta, which is the reciprocal of sine, secant of theta, reciprocal of cosine, and cotan of theta, which is the reciprocal of tan. So this would just be flipping, so 4 over root 7 instead of root 7 over 4 for sine, but I want to rationalize the denominator, so I get 4 root 7 over 7. For secant, I just get 4 over 3, and for cotan, I get 3 over root 7, and again, rationalizing gives me 3 root 7 over 3.